Yeah, I'm starting to see the comments coming in. So, yeah, this is a hydronic heating system. The boiler itself is that part over there. You got a lot of piping configuration here. Right now, I'm actually working on the wiring and controls part of it. So, all the piping I finished up last night. I still have to press all the fittings. But sometimes I like to do some of the wiring before I even do that, just in case I end up not liking something or that's the kind of the beauty of ProPress and having all these pipe clamps holding all the piping together temporarily is I could just make changes if I need to before I lock it all in. And yeah, this one's quite complex. If you haven't seen some of my videos about this latest system, this one's actually, the house it's for is actually not big at all. It's for like a small A-frame vacation home, like a sort of a cabin, but it has a zone of in-floor heating, two zones of in-floor heating, which is this. So that's your low temp zones, since there's a mixing valve here to knock it down. Those are the high temp zones, which actually there's only one main heating zone that's for a loft area, a rather small loft area, but they just have a radiator on either side of the loft. So there's a single zone valve with that splits to two, and then these other two are actually for towel heaters. Um, so Smallville, your question: how much so far is this personal business? So this is business. This is a customer I'm doing this for. These systems can get pricey, but in some cases, you might wonder why go with hydronics. Extremely efficient heating, especially when you get into radiant heat types. Like for instance, the shop I'm working in the floor, inside this concrete floor is heating pipes that warm up the entire concrete slab. Very efficient to heat, very cost effective. I'm sorry about the camera here. I'm trying to adjust everything, and my tripod is failing miserably. Let's see if that's okay. So what's the max temperature for the flooring zone? It is set to about 120. So it really just depends. Not all of them are going to be the same. It depends on what your system needs are. So if you have like radiant in-floor in concrete, the maximum you want to go is about 125 degrees. But if you're doing like a staple up system that's underneath some hardwood floors or something like that, you might want to go with higher temps, maybe up to like 140. I've even seen some as high as 160, but it all just depends on your application. And if you're using heat transfer plates, then it can come down. How hard will it be to transport? Not bad. I mean, they are heavy, but they're not unbearable. I mean, and you only always say you only got to move it once, so you get one or two guys on either end, usually just one on each end, and you heave the thing in, get it up on the wall, and you're done. Yeah, it's heavy, but I end up shipping these all over the U.S. So, this one's actually is going to California, believe it or not. And yes, there are some cooler parts of California that still need heating. So, I have another one that's going to Alaska. I just had one picked up from Pennsylvania. I'm located in New York. So really, these go all over the place. Yeah, so this one's gas. This one will be gas. You could actually just convert the same unit to propane very, very easily. There are electric systems I do as well. The boiler looks, the same, but inside of it is just a big heating element. They draw a lot of current, but they are 100% efficient. I actually built a home a few years ago, and I used an electric boiler to do all of my radiant heat, and it heated a big tank of water for my domestic hot water. So it's certainly doable, but sometimes it just depends on how much square footage you need to heat, and obviously your heat loss, but it can get pricey if you're trying to heat a big home. So, but it all just depends. I mean, my house I have is on propane. It's not necessarily cheap in general to burn propane either. I mean, one way or another, they're getting you. Best thing to do is build extremely tight insulated homes. Spend your money up front on that, and then your energy costs will be low. So I'm gonna just get back a little bit to wiring this. I'll check out some more comments in a second. So what I'm doing is running the power and zone controls. It is it's pretty complex. I usually do a video walking through all the parts of it. I actually just posted my latest video on my channel talking about this system before I started wiring it. So it explains a little bit about how it works. But I have tons of videos on walking through and fully building residential boiler systems. Lots of videos on it. So I'm going to actually start. I need to grab some zip ties. Which I'm running low on, so I need to make note of that. And hey, thanks for the comments, guys. I do appreciate it. So how many feet per pump? As far as how many feet, I guess what I'll just mention is every pump needs to be sized accordingly to a lot of different factors. First you start with how much BTUs are we trying to deliver by doing heat loss calculations, and that's what the home requires. Then we need to figure out what the zone sizes are, what type of heating it is. You need to calculate how many gallons per minute that you need to drive through those zones to deliver whatever amount of BTUs. Then you need to take into piping length and diameter into account, and then you basically crunch all the numbers, and you figure out how much head loss you have. Then you have to match a pump to how many gallons per minute you need and how many feet of head that pump can overcome. Then it comes down to efficiency. Are you driving that circulator to its maximum point, or is it running efficiently? These ones are actually variable speed pumps that can adjust according to temperature. So you could set the delta, which is the supply going into the heating zone versus what's coming back, and you could set a specific temperature you want that pump to stay at. So I'll have these set to 20 degrees, so that way, so if you're putting 180 degrees out into the zone, you're going to get 160 degrees back. Yeah, VFDs are the future. Yeah, I mean, to me, it's like, if you're not using these, I mean, they're certainly not cheap up front to purchase these variable speed pumps, but I mean, the pricing will come down just like anything else, and it's kind of a no-brainer if you're, I mean, if you think about it, if you're spending all the money on this entire system in general, to spend a few $100 more on a circulator. But I mean, not everyone has the money. Some people just literally, their boiler blows up and they need heat, and they don't have tons of money to buy all the fancy gear. So I get it. I mean, I build these, whatever the customer needs. I'll never upsell them on something that they don't need. I'll just walk through all the options and I'll work with them. The only thing I will not skimp on or try to save some money is by not building a correct system. I will not cheap out in any way whatsoever as far as it needs to function correctly, it needs to be safe. It needs to follow all the manufacturer's recommendations. I will not skimp on things like that. It's just not worth it. So, get this. VFD dependability. So, in this day and age, I mean, basically the internals of the pump, as far as the components, are the exact same as a non-variable speed. The only thing that comes into play would be the circuit board in there. And I mean, everything's state of the art now that, you know, these can run for a very long time, I will say. I haven't ran into, the only thing I have ran into was like a recall or bugs within the that they had in the first few runs of these, but then they work the kinks out and then they run beautifully. And as far as, like I said, the circulator itself pumping water, I mean, they're outstanding, they're proven. Where do I get the boilers? I get them from a local supplier. There's a couple of them near me that I deal with. You can't get these these boilers online. You might see some for sale online from some resale companies, but manufacturer only supports them through qualified suppliers, basically. Ground screws always give me trouble. Trying to keep them walking. There we go. All right. So that actually takes care of all of our power wiring or 120 volt. I can walk through that a little bit. So what I'm going to do is make this is the boiler, uses a normal typical standard plug, 15 amps. So I'm going to actually, what I do is I purchase an extension cord just like this. I'll cut it off right here, splice it, and bring it right into here to power this unit. And then you get a nice plug just like this that you could just plug right in instead of hard wiring this. That way you could plug the controller and the boiler right into a standard dual receptacle and have it switched so that way you could have a switch to just cut off the power to everything. The boiler itself has a switch. I mean, you could also put just these on their own switch, whatever you want to do, but by code you need to be able to turn it off. So then what I'm doing here is, because we have very low current draw, because all we're doing is 2 pumps, whereas there's up to multiple zone valves that you could be running off each of these controllers. These are very low amperage circulators, so we're basically just stealing the power from this one as well, bringing it up into that one. We're going to feed that on the same circuit. And I think that is it. So I just got to do the extension cord, tie that, and then I'm going to do our low voltage wiring, which are the 24 volt, all the zone valves here, and the aquastats. If you've never seen an aquastat, this is it. Not very exciting, but inside of this is basically just here's the heat sensor that so you put this up against the pipe, for example, like that. And you, let me zoom out here. Well, that's not working. Why is it doing that? Anyway, you would clamp this on the pipe, which would touch that sensor right to the pipe, and it'll sense the pipe temperature. And then you could set it for whatever. So right now it's set for 120 degrees. So what that'll do is it will you have the choice of an open or normally closed contacts with inside here you can wire to. There's a knockout on the bottom, knockout on the top. And essentially what's going to happen is the zone is going to just call for heat until it hits 120 degrees that it's set for, then it will shut off. Then there's another dial inside here, which is a temperature difference. And I have that set to 20 degrees. So what that'll do is turn on the boiler until it's 120 degrees. And then when it cools off 20 degrees, which means when it goes down to 100, it will turn back on. And what we're doing is heating towel warmers, hydronic heated towel warmers in a bathroom. So what it's going to basically do is just keep the pipe all the time at anywhere from 100 to 120 degrees to keep the towels warm, and you could adjust as needed. Pretty cool. I mean, if you do have a hydronic system, it's easy to add zones for things like that. It's kind of a little extra. It's not cheap necessarily because you're adding all these components, but if you have the boiler and you're making hot water, you can just run it. Another way to do it is actually run your hot water that's feeding your shower through a towel warmer, so that way when you are taking a shower, it's heating the towel. But to be honest, it takes quite a bit to heat a towel, believe it or not, and it's not very efficient to do so. But if you want it, anything's doable. And this customer wanted it. So I think we're going to wrap up for tonight. I have a few parts I got to grab to finish up the piping before I clamp and crimp everything. And then, yeah, just do our low voltage wiring, pressure test this baby, and we are going to then the next step is actually I turn these into like their own sort of pallet and I crate them up. So I palletize them here just by using 2x4, some framing, some OSB to wrap around it, and then we throw it in the back of the truck. We drop it off at the freight shipper, and then they ship it off to wherever they go. So stay tuned, lots more to go. This one is almost wrapped up, and you can see here we got another one ready to go. And usually there's another one sitting right here, which is I got to clean this shop out, make some more room because we have a lot of boilers to do before the snow starts flying. So I guess that is it. I'm going to sign off and see you guys soon.